Hi, my name is Christian, and I will be explaining the lower extremities for coming off the blocks. The lower extremities movements would include movement in the talocoronal joint, the tibiofemoral joint, and the hip joint. The movement in the lower extremity is very quick, so to properly analyze this, we need to slow down the clip. At the left ankle, the motion is dorsiflexion at the talocoronal joint, with the external force wanting to plantar flex, making it a concentric movement. The movement is in the sagittal plane with a medial to lateral axis of rotation through the malleoli. So the dorsiflexors are controlling the movement concentrically. The right ankle is similar to the left, except instead of dorsiflexion, the ankle plantar flexes to push off from the blocks. So the plantar flexors control the movement concentrically. At the left knee, the movement is flexion at the tibiofemoral joint, with the external force wanting to extend the knee. It is a concentric movement in the sagittal plane with a medial lateral axis of rotation in the femoral epicondyles. The flexors are shortening and the extensors are lengthening, so the flexors are controlling the movement concentrically. The knees have alternating movements, so as the left is in flexion, the right knee is in extension to push off from that front block. So the knee extensors are controlling the movement concentrically. The hips also have alternating movements, so as the left hip joint is flexing, the right hip joint extends. The external force wants to extend the hip. Because it is a fast movement, it is a concentric movement in the sagittal plane with a medial lateral axis of rotation through the femoral head. In the left hip, the flexors control the movement concentrically, while the right hip the extensors control the movement concentrically.
Hi, my name is Esteban, and I'll be analyzing the movement in the trunk for coming off the blocks. So for the trunk, position A was her in the blocks, and position B was initial contact. If you've noticed, her trunk was an extension. For step 2 of the muscular control formula, the external resistance is gravity, and gravity tends to flex her spine. Her extensors were isometrically contracting. The plane of movement was the sagittal plane, and the axis of rotation was the interior portion of the inferior vertebrae. The muscles that were shortening were the extensors, and the ones that were lengthening were the flexors. One would think that the extensors were working concentrically as she went from A to B, but what was happening is the hip extenders were the one controlling the movement. The extensors were just isometrically contracting to keep her core tight, and as you can see, she kept that spinal curve.
Hi, my name is Haf, or Ha, and I'll be analyzing the movement of the arms coming out the blocks. I'll be looking at the glenohumeral joint, the shoulder joint, the elbow joint, and the wrist joint. My first analysis, we're going to be looking at the shoulder girdle. And in the shoulder girdle, we're going to focus on the scapula. The scapula in the left arm is in retraction, and the external resistance is gravity, which wants the scapula to protract. And the movement is concentric in the transverse plane, and it's in the longitudinal axis. And in the movement in the left arm, the scapula is retracting and is shortening. The retractors are shortening, and the protractors are lengthening. And the retractors control movement concentrically. Now we're going to look towards the right shoulder. And the right shoulder movement is flexion. And in flexion, when it comes to scapula, it includes protraction, elevation, and upward rotation. And in this movement, the external resistance of gravity wants to extend. So in that case, which means the opposite forces, you have concentric movement in the triplanal, triaxial of the scapular joint. And in this, the flexors are shortening and the extensors are lengthening, and the flexors control movement concentrically. In the glenohumeral joint, it's hyperextension of the glenohumeral joint. The external resistance is gravity, which wants the glenohumeral joint to extend. And because of this, the movement is concentric, and the sagittal plane and the axis of rotation is medial-lateral through the humeral head. The extensors are shortening while the flexors are lengthening, and due to this, the extensors are concentrically controlling the movement. In the right arm, you have flexion of the glenohumeral joint, with the external resistance of gravity wanting to extend, making it in a concentric movement. Sagittal plane, it's in the sagittal plane, and the axis of rotation is medial-lateral to the humeral head. The flexors are shortening and extensors are lengthening, and the flexors are controlling the movement concentrically. Now we move on to the elbow joint. In the elbow joint in the left arm, you have flexion of the elbow joint, and gravity wants to fully extend the arm. Flexors are working in the shadow plane of the axis, which is the femoral epicondyle. And the flexors are shortening and the extensors are lengthening, which makes the flexors a concentric movement. And now you have the right elbow joint. In the right elbow joint, it's the same thing where the flexors are working concentrically and gravity also wants it to extend. But because the flexors are working concentrically and are shortening, the arm is going to be in flexion. In the wrist, you're starting out in extension of the hand. Because you started out in extension, the movement at B is flexion. And gravity also wants to flex. Because it's a quick movement, it's concentric. And this movement is in the sagittal plane, with the axis of rotation being the capitate. And in this, the flexors are shortening while the extensors are lengthening. And because of the concentric movement, the flexors control movement. There's also another movement that's also incorporated when coming from the set position and coming off the blocks, which is this shoulder rotation in the arms. The thing is, it's a passive movement because you still maintain that shoulder rotation. So there's really no concentric, eccentric, or isometric movement. It's just passive.